In 3D software, sometimes we'll encounter a seemingly simple but tricky problem, which is aligning two objects. In some situations, our models come from 3D scans, or some operations change the point number and position. Even though they look very similar, they are already two completely different objects to the software, so it's almost impossible to align them to the same position in a direct way. So I created an auto-alignment tool in Houdini. It used some ideas and algorithms from machine learning, so you can consider it as the most basic version of machine learning. If we only use the naked eye, manually aligning objects, it will take a lot of time and always end up with some degree of error. The process is often a simply random process of instinctively moving or rotating objects, then observing the distance between them and correcting them again. So why not leave this repeating job to the machines? If we visualize this process, we can see this node graph. Input an object, compare it with the target object to get the error value. Randomly move the object, compare it again. If the new error is less than the previous one, we keep the new results. If not, move it once again. This machine learning process is kind of similar to the famous sequence in the film Next. So I created my first simple solver in Houdini to help me keep repeating this process. I determined the error by finding the average distance of nearby points for each point, and then let the machine randomly move and rotate it based on that distance. This solver will keep those better results and move them again, so that our object will automatically move closer to the target little by little. This algorithm, also known as greedy search in machine learning, it always looks for a local optimal solution. Try to find the global optimal solution by accumulating. At this time, I found that this algorithm also leads to problem. In some cases, our picket gets stuck in one position because the rotation range is not enough. It's going to stuck there forever. So I introduced a new optimization technique in this solver, which is called hill climbing. This technique is also widely used in AI training, and its basic logic is to avoid the system getting stuck in a local optimum. It needs a random restart to help it temporarily leave the current predicament. The way I achieve this is to add a detection at each iteration. The range of rotation will change to a more aggressive strategy at intervals, such as increasing the range of rotation by a factor of 5 or reducing it by half. My next iteration of this system starts to focus more on the accuracy of the alignment. Once the error is reduced to a certain range, it becomes increasingly difficult to find a better solution. In this case, higher accuracy often means smaller rotation angles. When the system is stuck for a long time, it will further reduce the rotation range to reiterate and inherit the new range. It's a bit like a lazy version of gradient descent algorithm. In addition to this, I've also added a for loop each frame, which now tries to iterate 50 times per frame. Now this final version is a bit slower, but more trustable, can get far more accurate results than before. Although this small tool doesn't look as intelligent as generative AI and ChatGPT, but it's very easy to use and reconfigure in existing 3D workflow. You just need to drop this solver into a project file. You can also set the parameters manually and iterate over and over to get better results. Additionally, you can even change the random rotation to other properties for various other functions. Currently, this tool still needs to be improved to adapt to more complex situations, but there are many potential scenarios where it can be used in real production, such as aligning LiDAR scan and Gaussian splat, aligning created models with 3D scan. This case study is to represent the potential use of machine learning. Many people are hostile to machine learning, but machine learning is not limited to generative AI. We can use some of the concepts behind the machine learning to develop all sorts of interesting tools to embed in workflows. In the film and animation industry, machine learning will undoubtedly make our production process easier in the future.